Welcome to my one viewer. I hope it's gonna be 2 viewers soon. Growth is important in life. Yeah, so first thing I have to do is fix JavaX itself, because I upgraded to the new compiler, Java compiler version. That solved the problem with the big class file of Gazelle V that just broke. The new compiler works, but now I have to integrate it here. Before we were compiling for Java 8, now we're compiling for Java 11 to support some new features. This is the problem I mentioned the other day. The base system depends on the higher levels, so if it breaks, everything breaks. And there's this PHP in the middle of all of it. But I think it's going to be pretty easy to fix it, I hope. Let's see where my server view is. Here. I just say 11 here. And I hope that this already helps us. Not sure though. Oh, 2 viewers, great. I wonder who the viewers might be. No idea. Random people off the internet, probably. No, it's great that you're watching. Okay, this did not work. Why is it not using the new version? This is still saying 1.8. And that's stupid. Yeah, so we have to be creative now. Where is this 1.8 coming from? How can we change that? We could also go back to the old compiler, which worked fine with this 1.8 stuff. Temporarily, that's maybe an idea. I think that should be done. Okay, let's see. New compiler. And then we copy the old version here, and we restart. We restart something this here. And then I think I will use the old compiler, hopefully, getting us one step further. Maybe wrong though. I have a terrible runny nose today. I look like I drank too much or something. Just from blowing my nose, I have completely reddened it. Otherwise I'm fine, it's just some kind of whatever it is. It's taking longer, is it a good sign? Probably. Yeah, I have a pretty wild way of deploying things. In a professional setting, of course, you would have different stages. Code in development, and then code that is productive, code in production, and there will be more tests, and you would separate the 2 code bases, and so on. Java's long string cannot be resolved. I mean, that's pretty bad. When it doesn't find Java base classes, that's not very good. String cannot be resolved. Holy moly. But now it is actually saying source 11. That's better. Are we almost there yet? Oh, this is tricky. Fixing the base system. Oh, same problem. How on earth is this even possible? Not finding Java base classes. That's bad. Bad. Now that it says source 11, maybe we can use the other compiler again. Restart this again, try again, but why should that make a difference? Not sure. Okay, starting. Yeah, maybe I broke my whole system and it's all gone and we can never fix it. That's the worst case. It's unlikely though. Yeah, it's the same kind of stuff. That's a mess. How is this possible? Cannot be resolved. We are using which compiler? The new one. And it's not finding Java classes. And this is really annoying. This version is also not doing it. Oh my god. This is a lame stream. Oh, 4 viewers. What, 4? I mean, I knew of 3 people. Regular viewers. They're multiplying. But I have nothing to show except for broken base systems. Aha, this one is giving us 1.8 again, which is of course wrong. But otherwise, it's very close. It just has this Java 11 problem. Why are we still seeing 1.8 here? Translate, yeah. Yeah. All they see is broken stuff. Fantastic. I mean, I could just do the compilation of this thing on another machine that has not yet been upgraded. It's not tainted yet, basically. And then I can get back to compiling the actual things I want to compile. Yeah, oh, that's a good idea. Okay. It's called transpile for server. I think that's something that works. Yeah, here I was analyzing Java class files because this compiler made broken Java class files, and it's interesting what is in a Java class file. It looks quite different from Java source code. Here's some actual Java bytecode instructions, function calls, and some lookup tables, and lots of things. Although it's not that hard to read, it's pretty similar to Java source code. It's like almost a one-to-one relation there. Transpile for server, I think. Is that doing anything? Illegal access exception. It is trying. I think we're getting there. Just a bit slow. Making all public. It's Java internal. It puts public in front of all method declarations. It's required for some linking things. Oh yeah, okay, this worked. That's okay. Oh yeah, I think this was very good. Okay. Yeah, but it has the same compilation problem. Okay, transpiling this to Java is okay. Compiling it afterwards, not. But maybe we can do this manually somehow. Let's see. Index compile is one and it's so slow. Yeah, what if we call this directly? Index compile. What? Oh no, they got a problem already. What? No, that did not work. That's a great compiler error. This is really helpful. Okay, this is correct. There has to be a solution out of this mess. There's gotta be a solution. Let's kill this little thing here, the helper. Compiler helper, let's do it directly. Oh. Okay. I think we got the JavaX core thing compiled. And now we need to package this, I think. Oh, this is tricky. And all the warnings everywhere. Illegal access. We could remove this. I'm not using the illegal Java part anymore, I think. Uh-huh. At 1.11, that's wrong. You have to call it 11 now, Java 11. It used to be Java 1.1, 1.2, etc. Now they just have the number. They say it's Java 11. So where did I put this? I put this somewhere. Stupidly. Did I? I did. Is it the one? No. No, it's in the... Okay. There. Yes, I was not knowing. Now I know. So we hope to get this running, which makes the new JavaX, and then we're almost there. doesn't work like this, but I need to do it manually. Where is it? Nope. I'm even losing track of all the tabs here. There. Try this one. Nope. Fantastic. Compile. Ooh. Oh wait, maybe it works anyway. What? It doesn't contain the main file. That's bad. What is it? Am I using something broken here? I am. Okay. It's only the mild error. This is so many levels at once. I don't know if the compiler didn't compile the program or if it didn't compile the program that is used to compile the program. Because it's sort of happening at once. If we try the old compiler again, maybe then it's better. Another error that I know about, it doesn't know. So this is a show of errors. Cool, right? It takes longer, that is pretty good. Yeah, this one we can ignore. Oh, that's excellent. I think we have enough eyes watching to force the thing to be solved. I think that's the logic. If enough people are watching, things get solved for some reason. Okay. Oh yeah, we made a new Java X core. Let's save that right away. Hopefully fixed. And this should also contain the new compiler. And now, okay, we could start this helper again. This helper program just has a compiler running all the time, so it starts faster. And it's also running my DNS, so technically one of my DNS servers is offline right now. But there are two, so it's still reachable. Nice sound. Start, I think this. What is this with zoom? It's so zoomed. Okay, starting. Okay, now with the Java X-based system running, we could go to other programs. Maybe this, I just changed something here. Let's try to compile this. Yeah, okay, now it doesn't find the Java stuff anymore. Let's see, ECJ doesn't find Java package. Okay, if I kill this one again, force it to run the compiler directly, what then? Oh yeah. Okay, this one is just a bug that I made. Okay, so the problem is only in this helper program. So we're almost there. Oh yeah, successfully recompiled this module. Now we can maybe recompile Gazelle finally. Let's try. Oh yeah, that's cool. Wow. Was Gazelle running? Nope. Oh, what did I do? Yeah, seems like it. Gazelle V, it's starting on the other screen. Here it is. I made a nicer design for the frame. Here the Gazelle icon with transparency. Yeah, it's pretty good, right? Bigger font here. And this here, guess what this is? As I'm not a designer, but I'm a mathematician, it's of course a mathematical formula. If you can get guess the mathematical formula I used, you get a prize. You get the honors. Guess what the formula is? It's not complicated at all. It doesn't look 100% like I wanted it to. If you scale it bigger, it's a bit better to see. But it's supposed to be smooth here. So, guess the formula. What is it? I will reveal later. Yeah, so first thing I want to try to do is... Okay, this is the preview of the other screen. Yeah, screen selection, definitely. As I have two screens, we should be able to still select the screen here. And we could try to make this look better. Because this blurriness is just a thing I did, but it would not be necessary. We could show this perfectly unblurred all the time. And yeah, by using the integral image, that would be an idea. So the thing is called an image surface, and here it draws the image. And I will just try to replace the redrawing part with some image, some integral image logic. Okay, what does it do? Interpolation on, it chooses white. If there's no image, it fills with white. Okay. If there's an image, it gets the zoomed width and height, and it does some stuff to zoom the image. So this we will replace. Draw image itself or something. Yeah, take this out. What is this here? Well, this fills the remaining space. If the image is smaller than the surface, it fills this with white. That we could also keep, I guess. We just take this here out in a separate function. There. Draw image itself. This we could also keep, I think. There. Yes, I think that's it. Failed to copy something. Yes. Okay. We can make a subclass of it. Subclass image surface showing integral image. Because this blurriness, that is not nice. That is not professional. Yeah, let's try, why not? Make a subclass. Image surface. 3 eyes. Showing integral image. The thumbnail later. Special library that specializes in scaling images quicker. I don't need this anymore. It's some simple trick. You just scaled it down once and then scaled it down again, and it's supposedly faster than scaling it at once, which I don't know if it's true. And we have integral images, we have fast scaling anyway. All of this we can keep. We make a constructor. Image. And we still have the full image. Yeah, we also have the full image, I think. And this. And all we need now is just this one function. This should be a very short class. So we replace this. Yeah, there should. Oh yeah, we want to see which part of the image we actually need, and there should be this. Get visible rect. If we zoom in, we don't want to draw the whole image, just the part that's visible. And now we could use a function that scales the integral image. Scale buffered, scale gray image. That's a good sign. To do optimize. So it's not optimized. It's not so bad though. This does a multiplication for every pixel and a division for every pixel. And of course, as everybody knows, the optimization of this is addition, right? If you go through the columns, you just have a floating point value you add every time in a round, so you get rid of addition and multiplication for each pixel. But it's not the end of the world. It's pretty fine. So this is actually the one, but we want to limit it to a part of the image, right? The part that is visible. Yeah, we'll do that later. We just do the slow thing first. Maybe we print something. What does this take? This takes just the width and height, or just the width, something. Yeah. Exactly. Scaled image. And I think we just draw the scaled image, right? I guess that's it. And we say we are developing this because it's probably not going to work. First try. Oh yeah, print doesn't work because print is also defined differently by Java, and we have to call it by a different name. Okay, I just inherited the wrong class. Okay, that's close. Scale. There's no. Let's for now assume we have a black and white image. What's about? Where's my get zoomed with? Oh, it's private. Okay. Method is private. Cannot access. That's an easy fix. My nose has stopped running. It's good. Took the anti-hay fever pill. Maybe that's it. It needs the precise type here. Yeah, let's go with this for now. Okay, this should compile, I think. Slowly, but it compiles good. And we add it to the library by clicking here. Make standard class. So slow today, what's happening? Looking up. I mean, yeah, I did kill my DNS server. One of them. So it's possible that botcompany.de is not reachable anymore, or it just takes longer. It will ask the secondary server. It should still work. Okay, now we have this, and we put it in the Gazelle program. Where's actually my Gazelle program? Here. Yeah, the problem is the image surface is defined in the library. But we need the changed version that we just made. So we just changed this here. There's our image surface, and we use the new class. Double buffered image surface. Do we need double buffered? Yeah, I think it flickers otherwise. Yeah, we need this. Okay, image surface. Oh yeah, of course we need to put in a new image every time an image is made. So basically it's empty first. We make it double buffered. We say there's no transparency in the image, which makes things faster. I think that was that. Yeah, we need this empty constructor also. We can make it more robust actually. If there's no integral image, if there's just a normal image, we just go to the normal drawing algorithm. That's a good idea. Make it more robust. Yeah, now there is a problem with the DNS. So what we want to do is start only the DNS server, but not this compiler helper. Is that possible? That should be possible. Yeah, I killed my website. RIP. .759, but we can just run this one, I think. Yeah, I should not kill my whole website. That's maybe a bad idea. Yep. Come on, start. Oh no, I started the wrong one. I wanted to start the DNS actually. This is the one. Why are you so slow? Come on. Have some chocolate. Come on, start. Yeah, this is the DNS server initialized. So I think our site should be back. Yeah, it is. Good. Okay. Good. Some transpiler weakness, doesn't matter. Please work now. Oh yeah, okay. Whatever. Okay. And still, what's happening? Yeah, what can we actually do with image recognition after that? I think we could show the grid in a nice way. It makes the grid over the image. We could show the parts that are compressible, or we could start to make regions. If two grid tiles have the same color, they are connected to a region, and then we get these regions. And that way we can segment the image already. We want to find things on the screen, right? It should be as automatic as possible. Oh, let's see. Surface. Yes, okay. It's hard to type. I just need to tell it that we want our own image surface, not the one from the library, and I have to do this in 2 or 3 places. Because other functions that use the image surface also have to be recompiled. And here's some more nonsense, which is slightly annoying. But I'm happy that we got Java X back on track. I mean, I wasn't sure how long this was gonna take getting the system back. That should fix that one. And what is this one here? Auto frame title. I don't even remember this, but apparently I made this function. Auto frame title. It probably guesses the name of the frame when you don't give one. It makes up some window title. I assume that's what it does. Yeah, okay. Now the standalone version, which does not require the Java OS. That's the one we see here. And we can auto-update it by itself, I think. Oh yeah. There it is. No change visible, but that's expected because I didn't make the actual change yet. Preview image, is it used anywhere else? Nope, so we can screw this and just put the integral image in. Is it of the right type? It is of the right type. Yeah, we need this normal image also, because it needs the size of this and everything. But hopefully we won't render it, we just render the fast version. Okay, we also have this one, that's fine. Here. Yeah, so internship is ending. How will things continue? We'll see. Investor should call me. Next investor should call me. Oh, did you see the image resizing? Here, I made this all myself, including showing them the right mouse pointer. Here, every corner, you can drag the corners, you can drag the edges, you can move it around, it works really nicely. Just like a native window. But it's all simulated in Java. Incredible, right? Did I recompile this? Did I? Let's see. Oh, look, that's better. Okay. And what if we zoom out now? Oh, I say this is excellent. Is it doing the right? Is it actually doing it? Because if it uses the integral image to scale, it should be much smoother. This does not look very smooth. Let's check the output. That's not it. Oh, we don't see the output. That's of course stupid. Let's try now. Okay, it's printing the visible rectangle. Okay, and here we see how much of the image is visible. And It does mean that it is drawing the integral image, because otherwise it would go to this branch. So we know we're using the right drawing function. It may just be correct. I was thinking it should like look smoother, but it is kind of smooth. Just if you scale it down that much, there's no way to get this font looking really good anymore. I think it's fine. I just put a to-do here. To-do, scale only the visible part. Okay, would that be complicated? I mean, it wouldn't really be complicated. Yeah, we can just do this, sure. Clip. Oh, but we have to calculate where the clip starts and everything. Do we? No, not really. We just need the scaling factor. So we have scaling factor, and we have the clipping rectangle, and the width is the width of the clipping rectangle. Oh yeah, the clip is in output coordinates, not in image coordinates. You make space for some pixels. And here we just go over the clip area. Calculation is exactly the same. Look, it worked. This line worked even though the bracket was not closed. It's Java X magic bracket closing. But now it's completely correct. We start here, there, yeah. And we could of course save this in a variable to make it even faster. Is that correct? Almost. This is now called scaling factor. It's not an int though, it's going to be a floating point value. Let's see if that does the job. Yeah, no, it needs the coordinates converted. That's one reason why it's not completely smooth, because it works with integer coordinates on the original image. You could use floating point coordinates there and then do some more smoothing on the image level while you get the pixel. That might make it even more smooth, super smooth, you could say. Okay, so here we convert to integer. And hopefully that's it. Nope. Oh, yeah. Int and int. Okay. And now we check it out. Clip. We need the scaling factor. That's our scaling factor. And we need the clipping area. Which is, I think, just this thing that we get from Java. I think you always think one thing and then reality shows you another thing. Okay. Let's update Gazelle. Have you guessed what this function here is? Smooth curve. It's a sine function. Just the normal sine function. Just a smooth sine wave. Yeah, I mean, this looks like it works, right? I can scroll around. Yeah, I think that was a non-error code effort. See how here we see this stream. So what I do on screen shows up in the stream, and then it shows up in my preview window, and then Gazelle grabs it, and then it shows again because Gazelle is visible on stream. So what you see here is some delayed version of what's happening. Funny. Yeah, that's very nice. So now we need a screen selector, right? Let's put that in. Simple screen selection. How do we get the number of screens in Java? I think it was something like all screen bounds. Oh, I used the wrong search engine. Yahoo is not going to help me. Okay, screen devices is the fundamental function. And we get the positions of the screens here. The funny thing is my two screens have different resolutions right now. One is 720p, the other is 900p, and if I try to go left here, I can't because there's no screen to the left there. So I have to move a little higher, and then whoop, I can move to the other screen. It's kind of annoying. I just want this here to go over there. But, well, whatever. Yeah, this should be the right function. So, where do we put it? We put it up here on top of the image. North and center. Top controls. What do we do? Radio buttons or drop down, I guess radio buttons, right? Yeah, radio buttons are good. Let's get our screens here. And find out how radio buttons work in Java X. Here. Yeah, you just put some strings in, but I also need an action. Oh, the action is on the button group, okay. The buttons form a button group, and the button group I can have notify me, I think. And the user selects a button. Radio buttons. Take all the screens. We should have something like screen count, right? Screen devices. Yeah, how about screen count? Just a number. Screen count. Switch on the light here, I think. Professional ring light. Oh, it's a bit better. Kind of pale. Okay, screen count. Recount to the screen count and call it screen 1 and screen 2. And that should be our radio buttons. What? Top controls is already defined. Oh my god. Where? How? What? Oh, it's the other top controls. It's those here. So we have a new set of top controls. Silly me, I didn't notice top controls too. And some problem with radio buttons also. I think. Okay, yeah, sure. Need to call the function. What? No, oh shit. Aha, it's called toList and not asList. But I can fix that. Synonym toList with asList. See, so that's how easy it is to make a synonym in JavaX. I think that should do it. No. Aha, buttons in group. Okay. Okay. Nothing is ever simple. Yeah, there are different ways to arrange the radio buttons, right? Arrange them vertically or horizontally, so the function doesn't do this for you. You have to choose your orientation anyway. Okay, bracket problem. This should go. This one should close there. This one should close there. Easy. Easy stuff. Okay. It doesn't realize when it's ready to update. There is no "you can update me now" pop up. We could do that too, for sure. Oh, I see something. Look at that. Screen 1, screen 2. It just doesn't do anything. Haha. And we should center it, I think. Oh. We should center the controls. Centered line, yes. How do we make the buttons do something? Screen selectors, and we do. What do we do? What do we do? How do we attach an action to the radio button? These have no action, that's lame. On radio button change, that's pretty good. Yeah, exactly. Yeah, that's what we want. Let's improve this function a bit to reflect new JavaX coding practices, which look like this. Everything has a right type. Yes, okay. On radio button change, yeah, that's pretty good. On radio button change, screen selectors, and then we see, say, look at screen. Yes. Look at screen. Normally the first screen. And somewhere where we make the screenshot, we look at this variable area. What is the area? Yep. Okay, here, this is the one actually. Look at screen. Screen bounds or something, yeah. And we should make sure if the user suddenly has less screens than before, that we don't run into an error. See, these are the little things that the professional programmer thinks about. And the beginner would never, I think, come up with this. What if they have two screens, they select the second screen, and then they remove the second screen, and Gazelle tries to make a screenshot of the second screen? It would have an error, right? So I take care of this by taking the exact number of screens into account. I think that's okay, actually. Yeah, right now the standalone version of Gazelle doesn't remember stuff. The whole persistence thing that is in the Java OS, where the values are stored automatically, is not enabled yet. So it will forget its configuration when you restart. And we can put that back in. What's happening here? Yeah, okay. Screen selectors. I want the auto update back. The auto update was nice. Have to put that back in. Oh, come on, what's happening? Centered line is not applicable. Blah, 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 blah. Okay. Yes. This was bad style. This is the correct style, as of course you knew. I defined 3 colors for Gazelle. This is the light blue, there's the gray, and this is some other random color. This color I actually made by calling random color a function. I think I keep making random colors, and if I like them, I declare them official project colors. Oh, okay. Screen count is the number of screens, and I took the length of the number, which makes no sense. There's no length of a number. I was thinking the length of the list of the screens, in which case you need the L function, but I was wrong. Can you imagine that humans build like roller coasters? Humans build like things that are really dangerous but are usually safe. Humans make mistakes all the time. Like, humans are known to make mistakes, and still they build very reliable, complicated things. I mean, not always reliable, but still pretty impressive. Okay, let's try to click on screen 2. Look at that. It's super fast also. The drawing is perfect. Nice. Check, check. Cool. Okay, so I think the enable thing also doesn't work yet. If you disable it and enable again, it doesn't start again. I don't care right now. I think it looks here. Compression 62%. Nicely compressed. So we could show some grid here. One idea for the grid was that you take all the grid cells and you just move them apart a little bit So one way to visualize the grid is just to put some spaces in between the cells. Either that's a good way, or we just overlay something like the compression level. Yeah, how about an overlay? In this image surface class, we can put overlays over our image while it is being drawn. So we can just put that in there. Draw. There's this general overlay field where you can put in any overlay function here. How about set overlay? Set overlay. This. And we could, let's draw the compression level. Let's distinguish the compressed cells from the uncompressed cells. Let's see if we have this information here. It's in the strategy of the codec. Because it's just one strategy, it could have many strategies, and one of them is the grid approach. Codec.strat. Yeah, okay, we put it in the compression class. And we say draw overlay. We need to know the zoom level. And then we draw some stuff. And we make it translucent, right? Semi-translucent. Scaling factor. Okay. Here's our zoom. Let's just draw something. Test. Fill the whole area. Well, let's just make a random test. We need a translucent color. Let's say we make it green. And we make it half translucent. And we fill something. 10 is a bit small, 50 times 50 pixels in the original image. And here we get the zoom factor in. More zoom means it's showing bigger. Okay, so I think this is okay. Okay, and we link that in. Yeah, it doesn't matter when we do it. Whatever. Okay, overlay, set overlay. No, image surface set overlay. draw overlay. This. Stop. Nice. We are printing too much. Where's our visible rect? No, here. Oh, somewhere else. Here. Let's stop printing every time we draw something. Update. Do you see an overlay? I don't see an overlay, in fact. Cannot see the overlay. Where is my overlay? Yeah, we need to put all these error messages in the window somewhere. Right now they only appear on the console. Okay, what did I do? Create graphics is null. Draw overlay. Oh, we did something stupid, I think. What did I do? Yeah, I didn't tell it where to draw. Okay. Download and run. Yeah, there's our green rectangle. Completely ugly, but it is there. And if I zoom out, it gets properly zoomed out. Yes, perfect. So now we could show the actual grid. Here's the compression thing that compresses every grid cell. And we kind of grab the results here. Render element. Get rendered element. How about we store this just in some bit set? Make bit 0 for uncompressed, bit 1 for compressed. That's a pretty cool idea, I think. Bit set compressed elements bit set. Also, we have the concurrency problem. We want to get, yes, okay. We want to get the results in a different thread than we make them. So we always have to be sure it's multi-threaded. This Java class is not multi-thread safe. Is there such a thing as a synchronized bit set? Atomic bit set, yeah, that's a similar thing. Stack Overflow's upgrading. Currently read-only. Oh my god. Okay, yeah, there are various ways to do this. This one has a fixed length. Fixed length is fine though, right? Yeah. I don't think I have it in Java X either. Synchronize bit set. It's missing in the toolkit. Yeah, no, we don't have that. But we can work around it for now, it's fine. Press elements bit set. So here when compression was found for the element, we set the bit in the bit set, and we can make a function that gives us the result for an element. Is element compressed? We synchronize properly, and return the boolean. Yeah. Looks good to me. So here we go through all the cells. Maybe the grid codec should do this painting, because the grid codec knows about all the matrices and cells and everything. You should always put the code in the right object where the most information is, and just like the natural place. But it doesn't totally matter. Yeah, I mean, why not? Grid codec. Okay, sure, let's put it there. Codec, draw overlay. And we can save this Pico. It just means when there's an error, don't care. Just print the error. Move on. Yeah, let's put it in there. Whoop. Okay, so we need coordinates for each of the cells. How do we get those again? Here, that's the one here. Get the width and the heights of all cells. Make a function on it. Remember, the cells can have different heights and widths. So it's a bit tricky. go through all the rows. Yeah, we go through all the rows. We go through all the columns. We check if the element is compressed. This. Let's say we only draw the compressed ones. Then we need the position of the cell. We can make this another function, but then we have to complicated. Oh yeah, it's annoying. No. Grid LOL to image. We need to sum up the cell widths to get the current position. Partial sum. Here. And then get the right coordinates. Yep. Now I'm on track. Here, and this is the other coordinate. And then we have two more coordinates, which are this one and this one. That's our rectangle, and then we zoom the rectangle with our factor. And I think that's it. Then we hope we have the right function defined without any... why am I still going to Yahoo? Here, do we have the right function? Yes, we have the right function. This is the right function. And yeah, maybe we get some green squares. Yeah, bracket not closed. Yeah, I can totally believe it. I am a guy who doesn't close his brackets. Yeah. Oh, look here, I mean, yeah, I had too many brackets. Okay, that is very close. But from points, not point. Yeah, you're always believing, that's very nice. But not unreasonably so. Draw overlay. What? Wait, what? Draw overlay. That's here. That's in grid codec. So why does it not find this? Image surface. That. And this is the official class. Yes. This is garbage. What is it? Draw overlay. It says I do not see the problem. Oh yes, okay. We are using it from the library. I don't want to recompile the whole library because it's kind of big. So what I do is recompile the main program, but then I have to move the class over to the main program. The main program is relatively small, 10,000 lines, so it's quick to recompile. Before I did this, it was pretty slow and annoying. What's wrong here? The usual problems. This and that, that's probably... Okay. "45 minutes left. Yeah, what I have to do now is only because I was lazy. I could have made an automatic code editor for this, but I was too lazy. This one is this one. Yes. Which background? Which background are we talking about? Oh, got one. Oh, this one here. It's the anti noise foam. Professional anti-noise foam. And this one is, I think, a pipe. Rainwater, I don't know, whatever it is. Yeah, another one. Okay. Yeah, it's okay. It's not that bad. It's unusual, at least. You put more cool things there. Gazelle merchandise. Okay, we're almost there. One more function we have to move to the main program. Maybe it's done then? Nope, it's not. Okay. This. Stuff I have to do right now, I could really automate it. It would just be a little work. I could have spent more time on automating all the code editing. It would probably have been beneficial by now to first improve my coding convenience and then do the actual coding of things. It was just a bit too annoying. Didn't find the energy. So, oh, look at this. We have green stuff. Somehow I don't think the green stuff is what we actually... I mean, this is not right, is it? It doesn't change either, so it cannot be right. Oh, it's because we only have... Yeah, we are compressing only one screen. And then we're done. It doesn't compress anything anymore. we should definitely get into the continuous compression. Compress one screen, and when it's done, compress the new screen. Or we show the old screen in here. But right now, the two things don't match up. So we could are we getting notified when it is done compressing? Okay, first off, it is saving the screenshot in a file, which is a compressed Java file, which is cool, but we don't want to do this all the time. Fill up our hard drive with screenshots. It's a bit too much. So yeah, let's just say compression done. Make that an event. Compression done. And on the event, we start again, I guess. Here we start this. And on compression done. Yeah, how about this? We show the image when the compression is done. And only after the next compression is done, we show a new image. So here we would set both the image surface image and the overlay. Makes some sense, doesn't it? Yeah, it's a flag, right? Whether we show the current grabbed screen, show grabbed. Let's say preview mode. Show grabbed. Show latest grabbed. Here. All the images here. Yeah, and we restart the next compression. Start compression. Total. This just calculates the stats, I think. I don't think that matters. Yeah, it's not perfect, doesn't matter. Start compression. And in the end, we start the next compression. Error. This is generated code for event handling generated by Java X. Apparently it generated something wrong. Let's found this. On compression done. This line, column 13. That looks completely valid to me. One compression done. I think I put it in the wrong space. Yes. Okay. 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 That should be fixable. The logic is not quite right. The logic was not quite right. Here we make the integral image. And then we start the compression. If the last one is done, I think that makes some sense. Can also keep the complete we should keep the completed compression and the ongoing compression separately. If ongoing compression, if there's nothing right now, we start a compression. Something like this. I think. Where did this go? I don't even know. Okay, ongoing. Okay. Okay. Long-term compression comes ongoing compression, and we have completed compression. And then, when it's done, we copy over. Completed compression is ongoing compression, and ongoing is null, and grab from here. No, completed. And also we start another one. No, we do that in the other loop. And this is all called ongoing now. Wow. So interesting, the code is. Well, oops, what was that? I don't know. Okay, ongoing. Yeah. Let's try it. half hour remaining. Did we make any AI yet? Well, we show some green squares. Yep. Okay, this we can delete. That was the old preview method. And this just goes here. And hopefully it will compile. Almost. Yep. Okay, it's not called img, it's called .image. Important difference. And I think here we had another problem. Just need to pass on the image here. And now it will compile. I bet $5. It's gonna compile. Yes. Wow. Yeah, it shows it only after it compressed. That's okay. And here, look at that. Compressed cells are green. Check the other screen. And, yep. So fewer cells, and we get the compression levels in real time. Yeah, left screen is more compressible. Right screen less, so that's pretty good. And if you can do stuff on the screen, up here this is not compressible, even though it looks black, because it's not completely black. It's just a webcam with some noise. So we can definitely have a tolerance value for the, yeah, I mean, if we compress this kind of thing that's almost black, my idea is that we say we reduce the bit count. In the beginning it's 8 bits, it can be any grayscale value from 0 to 255. And if we find out it's mostly black, we can reduce the number of bits. We have maybe 4 bits left, which is a 16th of the brightness range. So we reduce the bits in half, and that's our compression. That's a very important way of compressing things. So we can handle things like that, where it's not exactly one color, but we still want to have a exact image compression. Our image compression is actually lossless. I decided. Not like JPEG, where it changes the image if it has to. It's supposed to be actually lossless. Yeah, an obvious variation is to vary the grid size. Smaller grid cells will probably compress better, up to a point. When the grid cells are just 1 pixel each, there's no way to compress anything anymore, because the 1 pixel is already compressed. Except if you have another second stage where the compression is compressed again. That's definitely something I will do. If you get this grid compression, then there's a second algorithm that says, maybe some of the grids are identical. Maybe I can just store the grid contents once and say all these grids have the same, yeah, like these for example, all these grids have the same contents, so we get even more compression. Multi-stage compression. Yeah, it's printing like crazy. Every little grid compression is noted and printed. CPU is not limited anymore. I have to put the CPU limiter back in. We are down to 8 FPS also. And the compression is actually slower. We don't get an image that often. However, for the compression, we can also take the last image that we compressed as a hint, because these things don't change at all. So we can compress way faster when we just assume it's the same and just check whether that's true. Yeah, so quick break maybe, I don't know. I'm happy with the result, but of course we have so much more we want to do. Maybe we could change the grid size as a last update. Yeah, let's do that. Number of grids, number of rows. It's 20 by default. And we can just make a little slider or something for the grid size. That's good. Let's do that, and then we have a break. Our weekend break, or our complete break, because the internship has ended. Oh my god. Team dismantled. Oh my god. Grid rows. YouTube is not receiving enough video. Oh, come on, YouTube. YouTube needs more video. I don't know. My connection should be great, so I'm not sure. Codec rows is grid rows. And now we put it in the top controls. Grid. Let's make the precise one where you should see the exact number, not just the slider. It's called spinner, I think. Int spinner or something. Double spinner, int spinner. It's the same as the int version, right? That's the same. Okay. Spinner, grid rows, and it needs like a minimum and maximum value. What's the minimum value of grid rows? We can have 1, right? We can have 1 grid row, which is everything is just 1 cell, or 2 maybe. And our maximum is whatever, because it's going to be kept anyway. Let's be reasonable, say. I mean, whatever, we can say more. 500. Okay. Make Java happy, and that should be it. Nope. Oh, it's just a type issue. Come on. Yeah. Computer's a bit slow. All the stuff going on at once. Is Gazelle not restarting? What's happening? Where is my Gazelle? Okay, what did I do? Oh! Wait, what? Oh, the value is not in range. The initial value of the rows is 0, so it's complaining and breaks the whole program just for this little thing. Your value is not in range. I have to crash everything. Not like just show the minimum value, maybe. I mean, just be a little relaxed. Okay. Aha. Oops. Okay, now we have 20 rows, and let's see. We go down here. Yeah, things are changing. Interesting. Okay, let's watch the compression level. 86% for 10 rows. 90%, I mean there's a maximum somewhere. 92%. 96%. 98%. This is getting worse now. Oh, I'm having less rows. I was thinking pixel count, but actually it's row count. Okay, we have to, yeah. Let's try more. 10 rows is, thank you, 10 rows is 98%, which is bad. We have to press enter or something. Maybe 73%, getting better. Yeah, 78 is even better. Okay, now it's going down again. It's a bit random. 74, 72, yeah, and so on. What if we have a lot of rows? Get a good compression, 51%. Getting a bit worse and a bit better. In the next step we want to do the details anyway, so we just take the grid cells as a starting point and then we look at the exact pixels and compress all of these. That's already pretty good then. Then I think we get a precise image of all these background colors. We should get one region for all of this here, excluding the text and the images. And then suddenly we see, oh, there's a hole in the background color. That's got to be a thing. So we say, okay, this is something we note. This is something we note. This is something. And then we find out these are all the same shape. They're all circles. Circle is definitely a special shape. So we say, oh, notable. They're circles. And voila, we already have made a semantic judgment. We say there's a circle-shaped thing on the screen, etc., etc. Oh, I have to put here, a label here. Let's do that as the last thing. Spinner. I thought it does this. Sometimes these functions put the label there automatically. Spinner label. Yeah, we have it. See, I just need to call the right function. Spinner with label. It will even try to make a human readable name. Out of the variable name, it will make something that looks a little more like normal language. Yeah, Gazelle is very busy now. Endless loop of compression. Just as it should. Yes, see, grid rows. Okay, sometimes the mouse cursor is stuck. Alright, now it's fixed. Let's try 100. Yeah, 100 is kind of bad, I guess. No, wait, is it even? It's not real. Yeah, no, 100 is okay. 60%, 61. And it's changing all the time. Very cool. So, not a semantic result yet, but we have a compression result. I think that's pretty good. Can be happy for now. Any more questions? Well, we can discuss the rest in the chat or something. Show green fix. Okay, thank you for participating, watching, etc. And see you soon.